Welcome to Web Handling. My name is Dave Roisum. This is a continuation of a mini-series on web machine design reviews. Here, we talk about which process steps are required, in which order, as well as what optional steps or provision for options that you might want to consider. We will build complexity up from just one step above a block diagram to something that approaches a proposal layout. We will do so in an orderly fashion so that decisions we make along the way are explicit rather than implied, or, worse yet, assumed. Every form of complexity is thus justified and incorporated as decision-making consensus is reached on each and every iteration. This top-down order is much better than starting with all the ideas first and then trying to simplify. Time spent here will reduce the purchase and operating costs of a machine while also increasing its reliability. The first step in the design process is to list the required process steps in the order they are required. Next, we must list variations in the process steps that are also required, perhaps to accommodate a wider range of products. These first two lists are things that are considered by nearly everyone involved as givens. Lastly, we will list provision for items. These are items that we're not sure we need, or that we may not need until some future date, or some future product. While flexibility costs, it costs the least when considered up front without necessarily committing to purchase. We could list these items as words or simple block diagram. In this clip, however, we will jump to a more elaborate block diagram that begins to faintly resemble a machine. We will use an ordinary coder laminator as a subject because it is familiar to many and because it illustrates most of the design considerations that you will find on most any machine. So, what must any laminator do? Well, it must unwind ply number 1 and coat on the side that will be married to ply number 2. Most coatings need to be dried. Lamination will be made with a nipped roller pair that we will discuss in more detail later. Finally, we need an unwind for ply number 2 as well as a winder for the laminate. Here we already are making decisions. First, that if Corona treat is required for coating, it will be pre-treated in the prior process. Second, that the product will never be sheeted in line, which is not common on laminators anyway. To this basic set of processes, we decide we also need an inline print station that is only required to make certain must-have products, but which will need to be bypassed or at least turned off for other products. Finally, we are not sure if we need to do trim slitting and trim handling now, but may wish to do so later. Here we include a provision for. This is merely an envelope in an environment which would allow that upgrade or rebuild to be done at any time with minimal effort. We may choose to do this before the order is placed, or perhaps next year, or perhaps never at all. At this point, we have a pretty good idea of the processes that will be central to our new machine. What we need to do next is question some high-level details in our initial sketch. The questions we now ask and the group consensus answers will largely determine what the next design iteration would look like. Here I've illustrated the principle with 8 questions. For example, unwind number 1 and the coder are both pretty high up into the air. Worse yet, the coder and presumably the operators would then be working over web number 2. It is usually a design sin to have much of anything over the top of a web run except the ceiling, and that is to reduce the level of contamination to the web product. So we decide that leg number 1 must be brought down to ground level. Also, someone in the group notes that dryers are much longer than the first sketch indicates. So an engineer calculates the dryer length given your particular solvent, solvent load, and maximum design speed. You can pause the clip and look over the other example questions and perhaps add a few of your own. Note that this approach is quite opposite the ordinary practice of many designers. That is, many tend to copy and paste an existing unwind design, attach it to an existing dryer, and so on. Perhaps they don't even bother with the component level and just copy an entire previous laminator that was close to the current application. What happens with this more conventional approach? Well, you tend to propagate both unnecessary complexity and previous mistakes to the next design, perhaps even adding more of your own. Also lost is any documentation of the choices and the decisions. You are simply presented with a layout that does not necessarily beg for critique of all the details. Now, I am not in any way suggesting that we design every part from scratch. No one does that. That would be wasteful and result in unreliable designs due to infant mortality. However, there is plenty of time to copy in details later. Once we decide which details are just fine for this new order, which details really need a rethinking, and which details can simply be dropped because the presumably heedless and unneeded complexity costs now and forevermore. Based on our questions and answers from the very first sketch, we are now able to make the machine look a bit more like it finally might. Note that we still don't yet copy existing details, rather just rough geometries that we know key processes must have regardless of the details. This first iteration then prompts many questions from the group, just as did our first sketch. Many of these are web handling related. Thus, at least a few of the team should have formal web handling training. Some questions undoubtedly would be process related, though we don't list those here for the purpose of brevity. Thus, the team would need to have at least a couple who are truly expert in the particular coating and drying method that your new product mix requires. However, no less important is operational expertise. Here, we do not necessarily mean one-time operators that were promoted to supervisor. We mean current lead operators who will be asking the embarrassingly tough questions like, how in the hell am I supposed to get that unwind roll into the stand? If you look through these web handling related questions, you will note that not only do we have mechanical concerns, we also have controls concerns. Here we note that drives become more important at this stage. The drive engineer on your team should then also have had formal web handling training, so that they can advise on drive zones and control strategies appropriate for the properties of your new web products mix. Sizing of drives and other components will come later. We just need to know which drive points are requirement and which are options that the web handlers must debate and decide on, just like anything else. Instead of continuing the finer points of mechanical design in another iteration, we soon need to start to look into some top-level drive details. Here, the web handlers might define 6 drive zones, though you might get away with as little as 4. This would be decisions that the web handlers need to make. A drive zone is bounded by controllable motors, usually with feedback from dancers, or, better yet in many cases, load cells. Each zone would have a separate tension setting based on web handling guidelines. Within each zone, the tension is nominally, but not precisely the same, as we will see in an upcoming clip. Also included at this point are torque control drives, such as one of the laminator nip rollers and an optional center surface wind drive, as well as possibly slitters and bowed rollers. We discussed the justification and application details for torque control drives in great detail in the web and drive and winding sections of Web 101, and we will not repeat those details here. And, as you should now come to expect, we again have many questions that need to be formally asked and explicitly decided upon. These decisions not only affect the drive size and cost and complexity, they can also have a very significant effect on mechanical design. It is no trivial matter to do a good center surface wind drive that does not degrade nip control, as we discussed in our 2-day winding class. It is even harder to make the controls for dual drive laminators and the center surface wind drive understandable to the plant process engineers, much less the operator, who will be expected to run the machine on a day-to-day basis. The subject of HMI, or Human-Machine Interface Design, will be the topic of an upcoming clip series. Stay tuned. Thank you so very much for watching this module in my Plant Practical video series. Stay tuned for the next clip where we will continue the design review process by getting into the design details of the building blocks of our web machines, rollers.